In this screencast, we introduce the notion of one-way chi-square. One-way chi-square has to do with categorical variables. Our last few tests have all involved quantitative variables. We did a hypothesis test for one population mean, for the difference of two population means. We did ANOVA, which was for multiple population means. One-way chi-square is a test for the distribution of one categorical variable. What does that mean? The distribution of a variable refers to the possible values the variable could have, along with how frequently it has those values. For a quantitative variable, a histogram gives us a picture of how it's distributed. We can see the typical values and how common or rare they are. So think of a histogram for home prices. With a histogram for home prices, you could see, oh, most of the homes are between $200,000 and $300,000, and there's a small percentage that are very expensive, etc. For a categorical variable, it's simpler. The visual would be a pie chart, and the whole distribution could be contained in a simple table. So here's the distribution of blood type in the United States. So there's 4 possible values for blood type: O, A, B, or AB. And the pie chart or the table both tell us exactly how often they occur. Type O blood, 44%, type A, 42%, etc. So one-way chi-square is a way to test whether a categorical variable follows a particular distribution. Suppose we wanted to know whether blood type in Norway was distributed the same as in the United States, the same as at 44, 42%, etc. So we might take a sample of 1,000 Norwegians, and this is the kind of data we might get. 413 have type O, 480 type A, etc. So one-way chi-square looks at one categorical variable, in this case blood type, and tests whether or not it is distributed according to some previous given distribution, some hypothesized distribution. So how are we going to compare the two? Well, the actual number of Norwegians in our sample of 1,000 who had type O blood was 413. But if the actual full Norwegian blood type was 44%, the way it is in the United States, we would have expected 440 Norwegians with type O blood. So in the United States, 44% have type O. So out of 1,000 Norwegians, we would have expected 440. We really got 413. We would have expected 42% or 420 with type A blood. We actually got 480. So we compare what we actually got with what we would expect if the blood type was distributed according to the given percentages that we got from the United States. Next, we use that data to compute the quote chi-square statistic. And that's in theory, at least we used to. Now it's done behind the scenes, and we're going to use technology, and you'll see how that works. But what chi-square does, it takes the observed values, subtracts off the expected values, squares them, divides by the expected, and adds those up. So if we were doing this by hand, we would take this observed 413, subtract the 440, which is about 27. We would square that and then divide by 440. We would do that for all of these and add them up, and that would be our chi-square statistic. So chi-square is a theoretical distribution like the normal distribution or the t-distribution or f, and we would use its properties to compute a p-value. For us, we're going to use Excel, the Excel function chi-square.test, to compute the p-value directly from the observed and expected, and here we get a p-value of 0.0004. And let's just take a break and see exactly what that looks like in Excel. So here's my table in Excel. Here's the actual values, the expected values. How do I get the p-value? I don't have to do anything very fancy. I go to Formulas, More Functions, Statistical. I scroll down here to chi-square.test. And then it wants to know where's the actual data, what you actually observed. Well, that was here. And where are the expected values? Well, that's here. And then it just gives you the p-value of 0.0004. So that's our p-value. And let's go back here. And now we can do the full hypothesis test. In Norway, do 44% have type O blood, 42% type A, 10% type B, and 4% type AB. So the null hypothesis is that is what Norway looks like. The alternative is that it's not. With the help of technology, we get a p-value 0.0004. So we reject the null hypothesis. We got a tiny p-value. When you reject the null, you have evidence that the alternative is true. We have evidence that blood type in Norway is not distributed as hypothesized up here. If it were true that in Norway, here's our rationale, if it were true that in Norway 44% have type O blood, 42% type A, 10% type B, and 4% type AB, there'd only be a 0.0004 probability of observing values, of getting observed counts, the number in each category, as far from the expected ones as we did. So that's a little introduction to one-way chi-square. It takes data and asks if one categorical variable is distributed according to some preconceived hypothesis.